Step under the yellow tape and welcome to the CSI Cambridge exam room. I'm your lead detective, and today we're cracking open Case File 1.7, Differentiation. Specifically, we're zeroing in on stationary points and their nature. You know, every single year, thousands of students walk into that exam hall, and they leave behind what I like to call loose footprints. Careless mistakes, vague theories, and massive fatal drops in structural marks on those high-tariff questions. The difference between scraping a B and locking down a flawless A-star? It usually comes down to this exact topic. Now, for today's investigation into the failing high-tariff question, I'm bringing along two of our rookie forensic agents. Let's call them Agent Alex and Agent Sam. Now, Alex is completely obsessed with loose facts, memorizing past paper marking schemes without actually understanding the math. And Sam relies on vague theories. You know, the kind of student who writes "it goes up and then down" and hopes the examiner is feeling generous. Neither of them are surviving the exam room right now. So let's put on our forensic gloves, because we are going to dissect the evidence line by line, figure out exactly where these marks are being stolen, and engineer a totally foolproof A-star response.
Today's investigation dossier is broken down into 4 distinct phases to map the exact route from a standard grade to top-tier marks. Phase 1 is the briefing. Phase 2, procedural sequence. Phase 3, examiner autopsy. And finally, Phase 4, critical execution.
Phase 1, the briefing, core principles of differentiation. Let's start by establishing the absolute law of the land when it comes to the theoretical foundations of stationary points. The syllabus guidelines give us a massive clue here. It says, top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. The principal examiner reports make this abundantly clear, guys. Memorization is just not enough to survive. This is exactly where our rookies mess up. Alex tries to brute force the exam by memorizing 100 different derivatives, but the second Cambridge throws a curveball, like applying it to a volume optimization problem. Alex freezes. Sam, on the other hand, understands the general shape of a curve but can't execute the algebra to save their life. To win, you need a connected, conceptual framework. You have to be able to take your differentiation toolkit and deploy it in a scenario you have literally never seen before.
The assessment objectives are designed to target 3 highly specific cognitive domains. Think of these as your 3 main forensic tools. First is knowledge and understanding. This is your baseline, right? Knowing your power rule, your chain rule, knowing that a stationary point means the first derivative is 0. But that's just getting your foot in the door. Then comes application. That's actually taking that derivative, building the equation, and solving for x. But analysis, that is where the A-star marks are truly won. Analysis is proving the nature of that point. Is it a maximum, a minimum, a point of inflection? And more importantly, you have to justify that mathematical reasoning with absolute bulletproof clarity.
So, the ultimate secret weapon of the top-tier candidate is this: cross-topic connections. To achieve those significantly higher marks, your mental architecture has to rely on precise definitions and integrating this topic with other syllabus areas. Listen, Cambridge is never just going to hand you a sterile, boring equation and say, differentiate this. No way. They're going to embed it in coordinate geometry or kinematics or some wild optimization problem about the surface area of a bizarrely shaped tent. You have to be able to recognize the fingerprints of a differentiation problem even when the question is wearing a disguise. If you see maximum volume or minimum distance, alarm bells should be ringing in your head.
Which brings us to a massive question. Why do students find applying concepts to unfamiliar contexts so ridiculously hard? When we pull out the magnifying glass and cross-examine failing exam scripts, it almost always boils down to a breakdown in systematic analysis. The student just misses the causal relationships. Agent Sam, for instance, sees a complex word problem, completely panics, and forgets that finding a maximum area is literally just a stationary point problem. They drop all the structural marks before they even pick up their calculator. We need to fix that reflex right now.
Moving into Phase 2, procedural sequence, technical methodology and process.
Okay, let's map out the exact forensic methodology you need to secure your method marks. The method mark strategy is your anchor here. Process is just as vital as your final numerical result. Actually, scratch that, it's often way more important. In Cambridge Math, that glorious final answer at the bottom of the page, it's usually only worth 1 accuracy mark, the A mark. The bulk of your grade is sitting in the M marks, the method. If your calculator slips, but your method is flawlessly laid out, you still secure the vast majority of the points. But if you just confidently write down the correct final answer with 0 working, you get absolutely nothing. 0. You must demonstrate systematic processing. Treat your exam paper exactly like a chain of evidence in a court of law. If there's a missing link, the whole case gets thrown out.
To make sure no method marks are left bleeding out at the crime scene, I want you to memorize this standardized 5-step procedural sequence. Step 1. Identify key elements. Highlight your variables, your constants, and critically, the command words. Step 2. Apply relevant principles. Explicitly write down the formula or the derivative rule you're about to use. Don't keep it in your head. Step 3. Execute analysis with clear working. Show the differentiation line by line. Step 4. Verify results. Look, if you found the x-coordinate of the stationary point, did you remember to plug it back into the original equation to find the y-coordinate? So many students drop a mark there. And step 5. Present in an appropriate format. Clearly state if it's a local minimum or maximum, and provide the exact values the examiner asked for.
Now, before we dive into the really juicy stuff, the examiner warnings, and the roadblocks our rookies hit, I need to pause this case file for a second. To ensure you never miss our weekly forensic breakthroughs and always outsmart the examiners, subscribe to Ace the Exams at Ace the Exams right now and turn on all notifications. Okay, let's get back to the crime scene.
Phase 3. Examiner autopsy, evaluation, and warnings.
Now things get intense. Let's open up the principal examiner reports, turn on the UV highlighter, and conduct a line-by-line autopsy on where students fatally drop their marks. These are the top 3 fatal mistakes that actively kill a grade. Mistake 1. Answers are way too vague. This is Agent Sam's signature move, writing the gradient is 0 in English, but never explicitly writing dy over dx equals 0 in the math. You have to speak the language of math. Mistake 2. Format and presentation are completely ignored. This is when a student fails to properly label their second derivative, or they leave their final coordinates buried under a massive scribble instead of stating them clearly at the bottom. And mistake 3. Answers are not specific to the given context. If a question is tracking the maximum altitude of a weather balloon, please do not just write x equals 4 is a max. Write the maximum altitude occurs at 4 minutes. Tie the abstract numbers back to the physical reality of the problem.
All right, red flashing lights here. We have a major examiner alert regarding terminology that you absolutely must protect yourself against. The reports show that candidates consistently confuse key terms when writing out their extended responses. Let's jump into our first live forensic workshop challenge right here. Imagine you're looking at an authentic exam source about a profit maximization curve. I'm starting a 60-second visual timer in my head right now. What's the critical trend variable that proves maximization? Is it just finding where the line is flat? No. Time's up. It's proving that the rate of change of the gradient is negative, but students will just write turning point instead of stationary point, or they won't clarify if it's a local or absolute maximum. When you are writing your final concluding sentences, this lack of precision is exactly where the examiner's red pen strikes hardest.
Let's move to workshop challenge number 2. Look at this snippet from a flawed student essay. I want you to pinpoint the technical mistakes that just killed their grade. On the left, we have vague terminology. The student wrote, "It goes down, then up, so it's a minimum." Bam! Structural marks dropped. Why? Because they never explicitly define the mathematical terms. You can't just drop words onto the page. On the right, we have the A-star approach, explicitly defining terms. You write, since the second derivative is greater than 0 at x equals 3, the stationary point is a local minimum. See the difference? You are proving your conceptual framework, you are using the proper notation to show the examiner you are driving the car. You are in total control of the evidence.
Phase 4. Critical execution, higher order assessment strategy.
Finally, let's debrief on how to synthesize all this evidence to secure the absolute maximum tariff possible. Top candidates don't just describe the math, they elevate their answers to analytical and evaluative levels. Look, the descriptive level is merely stating what you did. I found the derivative and solved for x. Great, you did the bare minimum. But the evaluative level, the A-star level, that involves justifying why you did it. Why did you choose the second derivative test, instead of just testing values on either side of the point using the first derivative test? Maybe because you evaluated the algebraic complexity and realized taking the second derivative was the most efficient error-free path. When you write out your final steps, that level of higher-order thinking translates directly onto your page through a clear, totally logical progression of thought.
Sometimes, a complex, high-tariff question will push you to evaluate 2 different mathematical models or alternatives. When that happens, I want you to use this exact comparative analysis framework. First, identify the similarities and differences in the models. Second, use comparative connectives like whereas or conversely in your written justification. Third, and this is crucial, support your comparisons with hard evidence. Use the actual numbers derived from your differentiation. Don't just say Model A is steeper. Say Model A has a maximum rate of change of 15, whereas Model B, you get the idea. Finally, draw conclusions about the relative importance. This isn't just crunching numbers anymore. This is elite mathematical communication.
So how did Agent Alex and Agent Sam finally crack the case? By deploying this specific forensic exam strategy every single time they faced a high-tariff stationary points question. Let's read their newly engineered full-mark process. Step 1. Deconstruct the question line by line. Highlight the command words. Step 2. Extract the relevant data. Pull the equations out of the text. Step 3. Select your analytical framework. Are you maximizing volume or finding a minimum cost? Step 4. Execute with crystal clear notation. dy over dx equals 0. Step 5. Present with correct terminology. Therefore, substituting x equals 3 yields a positive second derivative, confirming a local minimum. Boom. If you execute that checklist, you build an absolutely impenetrable wall around your method marks.
To really lock this framework into your mind and bulletproof yourself for exam day, I want you to engineer a quick memory hack right now. Create a custom acronym to recall these 5 steps under the immense pressure of the exam room. Deconstruct, extract, select, execute, present. DESEP, DESEP. Or honestly make up your own, whatever sticks in your brain. Write it at the top of your scratch paper the literal second the exam begins. When the panic starts creeping in during hour 2, that acronym is going to act as your forensic guide to keep you on track.
All right, detectives, we've completed the final autopsy. But before we file this away, I want to hear from you. Drop your current grade and your absolute dream target grade in the comments below right now. Publicly committing to that goal is the very first step in making it a reality. Don't forget to subscribe to Ace the Exams, enable those notifications, and keep running your past papers through this forensic framework. I'll see you in the next Masterclass Explainer. Case closed.